Hey guys, today we are taking a look at 1.3, which is solving equations with variables on both sides. We're going to be solving equations where there's going to be multiple steps to them, but most importantly, what's going to make these unique is that we're going to have variables on both sides of my equation. Because everything we've done so far, we've had variables maybe in multiple parts, but they've both been on the same side. So today we'll work on getting those together and solving. So taking a look at box 1, here we're focusing on collecting like terms. So you can see here, both sides of our equations are already simplified as far as possible. There's no like terms within the two sides of my equation. What I have to do here, since I have p on both left and right side of my equation, I have to get it so that my variable is just in a single place so that I can solve for just my single variable. So just get p by itself. So my first step here, I'm going to move either 5p or negative 3p over to the other side of my equation. It's up to you which way you move them. My suggestion is if you already have one side of your equation that is just a variable term, like here 5p is the only thing happening on that left side of the equation, I want to keep it that way. So what I'm going to do here to start with, I'm going to add 3p on both sides, just like I did in the last two sections where I can add something on both sides of my equation. I can do that even when it involves a variable. Because what happens then, my negative 3p and my positive 3p cancel out. I have 8p on the left side equals 24. And now it looks like a problem that we had from 1.1. I have 8 times p. The inverse of multiplying by 8 would be dividing by 8, so I get p equals positive 3. Especially when you have variables on both sides of your equation, you're going to want to check your solution, plug it back into the original, and make sure that it gives you a true solution. So in this case, if I was going to do that, 5 times 3 equals 24, minus 3 times 3, 15 equals 24 minus 9, which does come out to be equal. All right, taking a look at box 2. Another option or possibility for an equation that we could come across is that both sides of my equation are not already simplified before I have to get my variables together. So you can see here, both sides of my equation have a parenthesis with a coefficient out in front. So I'm going to go ahead and start by just distributing each of those two terms into my parentheses. So here on the left side, I'm going to go ahead and distribute my 4 into both of those two terms in the parenthesis. 4 times 3n gives me 12n, and 4 times negative 4 gives me negative 16. On the right side, 2 times 6 and 2 times negative n gives me 12 minus 2n. From here, it looks similar to what we had for box 1, where I have variables on both sides. For this one, we have a variable term on both sides and a constant term on both sides. So both numbers and variable terms on both sides. So for this one, it's up to you which side you want to push the variables to and which side you want to push the numbers to. Because remember, if we're solving an equation, we're trying to isolate that variable. So in this case, I'm going to get my n's on one side and my constants, just my numbers, to the other side. Looking at my numbers, I usually try and keep things positive. So I try and, if I'm going to add or subtract a variable term on both sides, I want to try and have that number at the end to be positive. So I can see if I add 2n to both sides, that's going to leave it be positive instead of subtracting 12n from both sides. But really, it's up to you. If you really prefer having the variable always on the left instead of the right, that's fine. You should get the same answer no matter which method you do. So I'm going to go ahead and do that. I'm going to go ahead and add 2n on both sides. On the right side, they cancel out. I have a total of 14n minus 16 on the left side and 12 on the right. And now it looks like a problem we had during the last section. I have to get my variable term by itself. So now I'm going to go ahead and add 16 on both sides. They cancel out. 14n equals 28. And my last step is going to be dividing by 14 on both sides to get n by itself. And I can see that we have positive 2 for our final answer. What we do have to prepare for, though, and we're going to talk about this in boxes 3 and 4, are some special cases. When we have variables that happen on both sides of my equation, we have this possibility where, in the process of solving, my variables are going to totally disappear. So we want to be prepared for that happening. So for box number 3, just like in box 2, I'm going to go ahead and start by distributing into my parenthesis. 5 times 3d gives me 15d. 5 times negative 1 gives me a negative 5. That still equals 15d. Just like we had up in box 1, I already have 15d on the right side all by itself. So I'm going to go ahead and move the other variable term over there with it. So I can see I'm subtracting 15d from both sides to get them together. But as you can see, something weird happens where 15d and negative 15d cancel out on both the left and the right side. So I'm left with negative 5 on the left side, and if I don't have anything on the right side because they all canceled out, the number we use to represent nothing would be 0. When we have this equation, negative 5 equals 0. There's no variable in it, but we know that there's no possible way that negative 5 could ever be equal to 0. So since it's not possible for negative 5 to ever be equal to 0, we know that this is not true, and the answer, the way we would phrase it, is that there is no solution. I'm also okay with you abbreviating it just to save some time and some pencil lead or some ink, and just saying NS for no solution. And again, that happens when your variables go away and the two things that you're left with are not equal to each other. Box 4 explores the other special case. I'm still going to start the same way I do every other problem. I'm going to start by simplifying both sides of my equation as far as I can. My left side is already as simple as it gets, 21 minus 7w. 7 times 3 is 21. 7 times negative w is negative 7w. Now I'm going to get my w terms on the same side. I'm going to add 7w to move that over, because again, right now it's a negative 7w, a minus 7w, so the inverse operation would be adding 7w on both sides. They both cancel out, and now I'm left with 21 equals 21, which we know 21 is indeed equal to 21. It's always going to be equal to 21. There's no x value, or in this case, w value, we could plug in there to make that untrue. So the way that we would phrase that, because it is always true, there's a special way of phrasing it. We say that there are infinitely many solutions. That one, you're almost definitely going to want to abbreviate to just IMS. So again, in quick summary for boxes 3 and 4 for our two special cases, in both of these, the variables drop away, so they're totally gone. Not d equals 0 or d equals 1. The variables, poof, gone, disappeared. If that happens and they're equal to each other, that's like box 4. It's infinitely many solutions. It's IMS. If poof, they go, bye-bye, variables gone, two numbers not equal to each other, no solution. Homework for tomorrow that you guys are going to be working on is page 23, number 4 through 26, just the evens. Again, if you have questions on anything that I explained on video, make sure you guys pause and rewind and back it up and listen to it again. If you're still confused, make sure you guys come ready with those questions at the beginning of class tomorrow. And if you want to get a head start and try working on some of these problems so that you guys are ready to ask me questions you're confused on in class, that would be awesome. Have a fantastic night, and I'll see you guys tomorrow.